Hi folks, my name is Matthew Harrison. I'm a farming systems scientist at the University of Tasmania. In this webinar we'll be looking at the first app of WaterCan Profit, which is the water price app. There's three parts to the decision support tool or calculator. In this webinar we're only talking about the water price app, so I'll include some links to the other webinars on the other parts of the app in the comments below this video. So if you click on water price, if you click on this home screen, you'll always go, if you click on the little icon, you'll go back to the home screen. Click on water price. The general rule of thumb is the way that you work through it is you start at the top and then you work through each item on the left hand side. Here is the scenarios. You can choose one or you can create your own. This means add a scenario. This means reset to defaults. So an easy way might be to copy an existing scenario, so you can just hit that button there, or you can delete by hitting it there. So what I'll do here is I'll click on one of the existing scenarios, and when you click on it you see the name change up the top. So if we go to crops, so we're on the Normanville scenario. Normanville is the name of an area. Now we have a number of crops that have been put in. Now these are put in already. So it's important to note that you can add as many crops as you like. So you can do that just by hitting this, add a new crop. So you can choose it from an existing scenario. So you can simply open up all the examples and you can say, well, I'm going to copy one of the existing ones, or I'll just take it from the default one, or do whatever you like. Or you can simply just copy one that's here. So you can click copy, and you can rename it here. This could be poppies, for example. Well, maybe not poppies. Maybe we could do grazed. Maybe we do fava beans. Okay. Now, if it's a rain-fed crop, you have this checked. If it's not a rain-fed crop, you uncheck this, and you'll see the water graph come up. And so that's essentially the water applied per hectare. So this is not a rain-fed crop. So now the yields, the water use, the price, and the variable costs are up to the user to enter. So usually what we've found in our work in building this tool is that farmers have a good indication of what yields are, particularly the most likely yield. So fava beans, the most likely yield for your farm for an irrigated crop might be 4 tonnes. Might be less, might be more, but this is just an example. What's the lowest yield you can think of? It might be 2 tonnes of the hectare. The highest yield might be 4.5. Okay, so what's the low, likely, and high water applied to the corresponding crop? So a typical water applied, and the way I'm moving this is rolling the mouse up and down. So I'm simply just hovering over it and rolling the mouse up and down, by the way. The alternative is that you change this number down here. So you can go up and down with the little arrow, or you can simply add a number. It might be 2 megalitres a hectare, and you'll see that change. The water applied for the highest yielding crop, it might be. Now, so the other thing to remember is that these are not linked to these. So the highest amount of water applied might not necessarily be the highest yield. So just put in the highest typical water use you would use for fava beans. So we could put that as in this example. Okay, we can say that's, just for sake of being even number, 2 megalitres per hectare. This could be 3, and this water applied, the lowest water applied might be 0. So that's fine. Okay, so you've got your distribution of water applied. Right, now what's the price of 1 tonne of, so it's price per tonne or price per bale if it's cotton, the price per tonne for fava beans. So you might remember a lowest price of 300, a higher price of a typical price for fava beans of 500, and the highest price you can remember of 600. You can research it or do whatever you like. I actually put that in the wrong one. 600. Now we've got the variable costs. So the variable costs are what's your lowest, your likely variable costs, and your high. Okay, so same principle. So I'm just using examples here. These numbers are not realistic, but they're just for the sake of example. so it might be 600. Okay, so we have our variable costs. We have a distribution of variable costs. So we have faba beans. Now for dryland wheat we have this checked, so we simply put in the same thing, but it hasn't got water use there. So you put in your prices, your yields and your variable costs, and that's it. You can put in as many crops as you like, or you can delete them all and just have one. So that's totally fine. Then what you do, so you've done the scenario, we've done the crops, we're on to the final one, we hit water profit by price. Now we've got a graph, it's simply water price. So as the name suggests, as the water price increases, the profitability in dollars per hectare decreases. So if your water price was $100 a hectare for this example, when you mouse over it will tell you what's the most profitable. So it's saying at a water price of $100 a megalitre, faba beans are $1,320 per hectare. The least profitable are dryland barley and dryland wheat. But if we go out to a water price of, and you can change the maximum scale on this, if we go out to a water price of, for example, and it is quite high in some places and in some seasons, we might have a water price of $700, of $600. Now what we see when these lines cross over, these horizontal ones are the rain-fed ones, are the dryland ones, because water price has no impact on profit margin, which makes sense. So at what point does that line cross over? Really what we're saying is that nearly $600 a megalitre, not quite, but nearly, is where faba beans, this top line, crosses over with the horizontal line, which is dryland wheat. So anything above $600 a megalitre, dryland wheat becomes more profitable, and that makes sense because the more expensive it is, the less your profitability of irrigated crops. Now, as you can see, the bottom one there is it arranges the colours in terms of the line type. So the bottom one is canola. In nearly all cases, there you're above about $240, $250 a megalitre. Canola's making a loss. You might say, well, that's not a very high water price, or it is a high water price, but canola profitability seems low. So in that case, you might want to go back and say, okay, what numbers did I put in for canola? Click on canola, and then you might say, well, now does the water applied look realistic? 3.5, 4, 4.5 for my farm. Now these numbers may or may not be realistic. You might say, well, for a rain-fed canola, 1.5, 2.5, for irrigated canola, 1.5, 2.5 is reasonable. Probably would have higher yield for irrigated canola in a likely year. I'm just making this up. And the lowest yield might be higher. So we just change those two, and in that way it will automatically save. Go back here, and we now see that the canola, that light blue line, is much closer, so the profitability is increased. But you might be interested in dollars per megalitre, and many farmers are, many agronomists are as well. So if you click on dollars per megalitre, you see that there's no rain-fed crops because there's no megalitres applied. And you can see that the slope of the lines are parallel. So faba beans is nearly always the most profitable, and that's a significant message. Irrigated wheat is nearly always the least profitable. So that's a message in itself. Then you've got these other tabs at the top here. I often find this most likely one most useful, but just briefly, these talk about variability. So that the width of that bar, and if they overlap, means that the difference between them is not significant. So there's no real difference. If that bar doesn't overlap with the other ones, it's clearly different. So that's crop price. So that was crop yield. This one's crop price. Same principle. Then you've got the variability for water applied. You can see that the faba beans, the top one there, are much more variable than the other crops. And then you've got distribution of variable costs. So that's all the water price app is. I'll see you in the next webinar, and thanks very much for watching.